Hello everyone, Medics Tutor here. Today we're gonna be doing our unit 6 in functions, right? Grade 11 functions. And we'll be looking through 6.1 to prepare for the upcoming test on Monday. Right? Upcoming quiz. Sorry, there's gonna be an upcoming quiz on Monday, and I'm gonna be walking through 6.1, and we're gonna be preparing for it together through this video. All right. So, let me just get a pen real quick. So, over here, we can see that a periodic function is a function whose graph repeats at regular intervals. So, what this means? This means that at a regular interval, right, a graph will keep repeating itself. Let's say that means the y values at one point and the y values at the other point would be the same, and they would just keep going on and on and on and on. Let's take this graph for example. Let's take this graph for example. Over here, we can see that this graph gonna just keeps going on and on and on forever, and there's gonna be an arrow here. It's just gonna keep going on and on and on and on forever. This is called a sine graph, right? It's a graph of the sine function. So over here we can see, let's take any random y point. Let's take a y point here. We can see that this y point would continue from here to here, and it would just keep continuing. Or let's take this point, continue from here and here, or maybe even the max point from here to here. So these 2 points are continuing on different x values where their y values are the same, right? And these 2 points here share the same y value and they're on different x points. But now, if you look here, you can actually see that, let's say there's a point at 540, right? This point and 180 here, they both are actually repeating at the same interval, which is an interval is basically like it's when you add a value to x. Like, let's say for example here, for this graph, the interval is 360 because this is one cycle, right? This is one cycle. I'll explain what a cycle is later on, but this is just to help you guys visualize what a periodic function is. So this here would be one cycle, right? So from a point at 0, let's say y equals 0 here, right? So this is going to be 0 comma 0. This value repeats when x is 360, right? Now if you look here, we do 180. We have 180. 180 plus 360 is 540, right? 180 plus 360 is 540. And we can see here that the y values are the same. Therefore, we can determine that the interval is 360 because the y values keep repeating at an interval of 360. This y value repeats here, this y value repeats here, this y value repeats around here, this y value repeats around here. So the graph is kind of repeating in intervals of 360 degrees. Next, we'll get into a cycle. A cycle is the smallest complete repeating pattern of the graph. Just put a marker there. The cycle. So what this means, so you can see how we were talking about intervals just now, how the y values keep repeating at the same interval, right, at the regular interval. Now a cycle is gonna be where there's only like one repetition. There's only one part. No, there's only the part which is being replicated over and over and over again, right? A cycle is a part in a periodic function which is being replicated over and over and over again at regular intervals. So the simplest cycle here is gonna be this. This is gonna be a cycle, because here, I'll help you guys actually highlight this. Here, if I highlighted this, right, we can actually see that if you duplicated this, right, if you duplicated this and if you brought it back here, we can see that the graph is just a duplication of it. It's just like the same. And over here we can also see that since, let's say here at the x value of 0, the y value is 0. But when you add 360 to that, right, when you add 360 to that, right, when you add 360 to that, this, the y value, the y values here become the same. So here the x value is 0, here the x value is 360, yet they share the same y value. So therefore, a regular interval is 360. Now that we have been talking about regular intervals, we can come over here and kind of see that we talk about a period. So period is the length of one cycle, which is also the regular interval in which a function graph keeps repeating at. So you could say that a period, let's highlight this graph again. I'll highlight this graph again. This is the simplest, the blue graph is going to be the simplest graph, one graph which keeps getting replicated over and over again towards the right. Right? So now we take this graph and we look for the length of one cycle, meaning how many x values it is taking to complete this one cycle. Here we notice that it's actually 360 degree. It's actually 360, the x. So from 0 to 360, it takes 0 from 360 for one cycle to complete. So therefore it takes from 0 to 360 for this entire cycle to complete. Right? Now you could add 360 to 360 and figure out that this cycle completes the same way this cycle does. Therefore, they both share the same period or the same interval. Right? Now we can get into the axis of the curve. The axis of the curve is the horizontal line that is halfway. It is halfway between this entire graph, right? It's exactly halfway between. It's the average of this graph. So it's going to be running through the middle. For this one, for this graph, right? The axis of the curve is going to be this graph this line I'm highlighting here, which is the x-axis, right? This line here, which is the x-axis, is gonna be the axis of the curve because it's exactly in the middle, or it's exactly the average of this entire graph, meaning that from the maximum value, it is the exact value away. It's the exact absolute value away, right? It's the same amount of value away from the maximum point on the graph than from the negative point on the graph, the minimum point on the graph. Now we can get into equation of the axis curve. So here we can kind of see that as I stated earlier, that the axis of the curve is halfway between the maximum point and the minimum point, right? So what we could do is we could find the maximum point. We could find the y value for the maximum point, y max, plus y min is gonna be divided by 2, because that gives us the half. So what we're actually doing here is we're finding the average of both of these points. So this point here and this point here, the minimum, we're basically finding the average of the minimum and maximum point, which will land us right between them. Right, now that we have that down, we get to the amplitude. So the amplitude is so over here we mentioned that this line, right? Sorry. Over here we mentioned that this line, right, the x-axis, or the line, or whichever line is exactly between your sine function, right? Whichever line is exactly between your sine function, that's going to be the axis of the curve. Now for the amplitude is going to be the absolute value, right? The absolute value of this line, which is going from the axis of the curve all the way up to the maximum or minimum value, right? So the amplitude is actually the distance that it takes from the axis of the curve to travel up to the maximum value or travel down to the minimum value. And the amplitude has to be the same for the maximum value and for the minimum value. This is because the axis of the curve must always line up between the maximum and minimum. It should have an equal distance from both. That's why in this equation we find the average. Now to find the amplitude, right, we could apply some logic here, right? Let's say this is the minimum value. Let's say this is the maximum value. We could find the distance between these two values, right? I'll draw two lines here. This line represents maximum. Here, I'll color code it a bit. So the blue line here represents the maximum value, whereas the green line here represents the minimum value, right? Right, min. The black line represents the difference of value in them, right? So if you do y max minus y min, you get like the difference between the maximum value and the minimum value. Now to find the amplitude, since we know that the amplitude is just how many values you have to go up by or down by to reach the maximum point or the minimum point on your graph. To get the amplitude, we know that axis of the curve, right? Axis of the curve is always between your graph. Therefore, when we find the difference in values, right, or when we find y max subtracted by y min, like maximum value subtracted by minimum value, we divide it by 2. This is so that we can find the value of the amplitude, right? I hope that makes sense. So we do y max subtracted by y min, and we do divide that by 2. Y max subtracted by y min divided by 2 is going to be the value for the amplitude value. The maximum value, once again, I'm going to be repeating because this is really important. The maximum value is going to be the highest or the largest value your graph touches, and the minimum value is going to be the least value your graph touches, right? The least. Actually, I'll color this green. The least value your graph touches, I'll color this blue. The maximum value your graph touches. So the blue point here is gonna, so here you could see wherever this peaks up, right? Wherever this peaks up, this would be your maximum value, wherever it peaks up. and wherever it goes down but comes back up, right, that's gonna be your minimum value, which is right here. Now we can go down here. Mr. T is usually just gonna say maximum or minimum, but these are some vocabularies he might use on the quiz, right? So the peak is the maximum point on the graph, and the trough is the minimum point on the graph, right? As we stated here, minimum's the least, the y value which is the least, right, that your graph touches, and the max value is the highest y value your graph touches. Now we can try solving this question. You guys can try solving it on your own. I'll give you guys some time for that. Pause the video if you want to. Alright, now we will solve this question together. So now we want to state the maximum and minimum height of the ride. Here, when we read this question, it says that the graph shows Sean's height above the ground as a function of time as he rides a Ferris wheel, right? We can kind of draw out a Ferris wheel here. It's not going to be perfect, but it looks like a Ferris wheel. We know that a Ferris wheel has to be lifted above the ground, because if it's like, since it's going to be spinning, right? If it's touching with the ground, it's going to kind of generate friction and it won't really work efficiently. So we know that a Ferris wheel has a Ferris wheel has to be like levitated above the ground at a certain point. Here we can see that the minimum value of the graph is at 1 and the maximum value of the graph is at 7. Right, I'll write that down here. This is because our graph, the maximum value our graph ever touches, right? The maximum value our graph ever touches is going to be 7 meters, and the minimum value our graph ever touches is going to be 1 meter. And since this graph, since like this graph and this graph and this graph are just copies of each other, and it just keeps going on and on and on and on and on and on continuously, we know that this is forever going to be the maximum value and this is forever going to be the minimum value. Here I'll state that the maximum value is 7 and the minimum value is 1. Now we want to try imagining what the Ferris wheel would be like. Here we can see that the Ferris wheel, like I stated earlier, the Ferris wheel can't be touching the ground. It has to be levitated above the ground. Here we can see that the Ferris wheel has been the lowest amount, like the lowest amount of height you can actually reach while sitting on the Ferris wheel is gonna be 1 meter above the ground. It's still gonna be 1 meter above the ground. Therefore, we can come to a conclusion that, let's say this is our ground, right? Our Ferris wheel is actually lifted 1 meter above the ground. Oh, so it's 1 meter above the ground. Now we can see that over here, the maximum height we can reach is 7 meters. 7 meters above the ground. So we could kind of draw our Ferris wheel here. We could write 7 meters here, right? To find the diameter of the circle, right, we could do 7 subtracted by 6, as it'll give us the horizontal line. It'll give us the value of the horizontal line that I just drew here, which is the diameter. Since on a circle, a diameter is when a straight line connects from one end of the circle to another, right? This is a straight line, which this right here is I'll just draw the circle again. Diameter. So we can see that this straight line right here is is actually connecting from one point of the circle to another point of the circle, and it has to pass to the middle of the circle and to be called a diameter. From here, we could see that the highest point you can reach on the circle is 7 meters. Lowest point you could reach on the circle is 1 meter. So you would do 7 minus 1, right? 7 meters minus 1 meters equals 6 meters. Therefore, you can come to the conclusion that the diameter is 6 meters. All right, I hope you guys are here with me here. What I basically did here, I know that the Ferris wheel has been lifted 1 meter above the ground. The maximum height you can reach on the Ferris wheel is 7 meters. So it's like 7 meters tall above the ground, right? The highest point you can reach while sitting on the Ferris wheel. All I did was do 7 minus 1, which gave me the diameter of this Ferris wheel. It gave me the actual size of the circle, the height of this circle, the height of the actual Ferris wheel, not the height how much it's been lifted above the ground, not the height how much you can reach maximum above the ground. This gave me the height of the circle itself. Right? Now to find the radius, right? Or the or the amplitude, right? To find the radius, I could do 6 divided by 2, which is 3. Now we can actually come to another conclusion here, that 3 has to be the amplitude. You want to know why? Because if we come up here, we can see that the equation for the amplitude is y maximum minus y minimum over 2. And once you come down here, you kind of have this. You can write this, because we're dividing it by 2 here, we could also write this as 7 maximum value. We could write this as maximum value subtracted by minimum value divided by 2, which is going to be also 3. So this tells us that from the middle you need to go 3 units down, or from the middle you need to go 3 units up to reach the maximum height for the circle or the minimum height for the circle. Now if we want to find what the midpoint of the circle actually is, or where it lays above the ground, right, we could do 7 plus 1. We could do 7 plus 1 divided by 2. This is because we're basically finding the average here. We're finding the average of these 2 points, which should give us a value that's exactly in between of both of these points. So 7 plus 1 divided by 2, the value for this is gonna be 4, right? Now if you come back up here, we can actually see that the equation of the axis is also y max plus y min, maximum y value plus minimum y value divided by 2, right? So here I did maximum y value plus minimum y value, and I kind of divided that by 2 over here, which gave me this value for 4. Now if you see here, this value of 4 is actually kind of exactly in between 1 and 7, and it takes 3 units, which is our amplitude value, right? It takes 3 units from 4 to go up to 7, and 3 units from 4 to go down to 1. Well, what else is a value for which you need to add the amplitude or subtract the amplitude to reach the maximum or minimum value? It's the equation of the axis, right? So you can come down here and you can conclude that 4 is the equation of the axis. 4 is the equation of the axis, and we can see that it's exactly between our graph. It's averaging right between our graph. And then we could kind of draw a line here, right? I'll make this line green. we could kind of draw a line here and notice that this is 3 units above this line, which is our amplitude value of, once again, our radius. 3 units above above this line, we're gonna reach 7, and 3 units below this line, we're gonna reach our minimum value, which is 1. Right? So how long does the Ferris wheel take to make one complete revolution? Here we could kind of see that this value goes up here and then it goes down here. This is, we could call this as one cycle, right? Because a cycle is basically, a cycle is like the part of the graph that's being replicated over and over again. As we could see here, I'll color these differently. This graph is the same as this graph, and this graph is the same as this graph. So they're all just copies of the black graph here. And from the black graph, we can actually notice that the black graph is 8 units long. So it takes 8 seconds for one entire revolution of the Ferris wheel. So we could say 8 seconds for this question. 8 seconds. So now we can write, what is the amplitude of the curve and how does this relate to the Ferris wheel? So as we kind of figured it out here, the amplitude of the curve is 3. Right? A equals 3, right? And how does this relate to the Ferris wheel? This is the radius. Is the radius of the Ferris wheel. This is the radius because this is how many values it takes from the midpoint, right, to any other point on the circle, like from here to here maybe, or maybe even here or here or here. It takes 3 points or 3 values, right? It takes 3 units to go from the midpoint to 7 or to go from the midpoint to 1, right? And our midpoint is located at 4. So we could write, now we could determine the equation of the axis of the curve. We already kind of figured it out here. The equation of the axis of the curve is y equals 4. We applied this formula and we figured the logic behind this formula. We applied the y max plus y min formula, which is right here. We could do it again if you want. We could do y max plus y min by 2. Our maximum value is right here. It's 7. We could do 7 plus 1 by 2, which is 8 by 2, which is 4. So our value is correct here. If we want, we could do the same thing here. We could do it with the formula. We could do y max minus y min divided by 2, right? We could do 7 minus 1, right? 7 minus 1 minus 1 by 2 equals 6 by 2, which is 3. That's our amplitude value. So what is the range of this function? So the range of the function is, we can see that the lowest value here is kind of 1 and the maximum value here is 7. So we write range is, you put a colon. Range is always applied to y, so you do y is from real numbers, where 1 is the least, right? 1 is less than or equal to y, or y is between 1 or 7, so it's y is less than or equal to 7. And that's it. We're done for that part. Now we can kind of come down here and we can look at this question. Determine the term periodic. Determine whether the term periodic can be used to describe the graph for each situation. If so, state the period, the equation of the axis, and the amplitude. Right? So once again, what a periodic function is. A periodic function is a function whose graph repeats at regular intervals. If we come down here, this graph, even without highlighting any point here, we could see that it's kind of repeating over and over and over again. And so we could write that yes, it is periodic, because we can see that this y value is kind of repeating here, this y value is kind of repeating here at regular intervals. Now they want us to find the period. So how I'd go about doing this question is, I would kind of just pretty simple to highlight one cycle, right? One cycle is the cycle that's being replicated over and over again in the graph, right? But more logically speaking, you could also do you could kind of subtract like an x value with the same y value, right, to get the period, but I wouldn't recommend it. But we could try that here for this question, right? Here we have, let's say, so let's say we're doing it the logical way. We're like subtracting the x values, right? We would do x a minus x b. X a is right here, x b is right here, right? So x a is the value where the y value is the same as in xb, right? The only difference is that xb is part of the cycle, like the original cycle, and xa is part of the duplicated cycle. Now here so now to solve a question like this, I would not recommend solving a question like this. But if you want to solve a question like this, here you need to kind of find the scale, right? You need to find the scale. Here we could kind of get a rough estimate of the scale. So I'm gonna go with trial and error to help me find the scale. I see that this goes from a random number to a random number to 6. I'd say 2 and then 4 and then 6 and then this be 8, 10, 12. So now that I have these values, I got this to trial and error, right? I know my xa, where my y value is -4, and my xb, which is 2, and my y value is also -4 there. I would substitute I'll substitute these values in. I'll do 8 minus 2. 8 minus 2, I get 6. Therefore, the period is 6, which you could also see by the highlighted graph. The other way to do it, which I would personally do or recommend, is just highlight the cycle, right? Highlight the cycle and see the difference from the beginning of the cycle to the end of the cycle. Here we can see that it ends at 6. Here we can see that it starts at 0, so it's kind of 6. The period is 6. You're gonna get your answer either way. I just find the highlighting method more simpler or easier. Now you do the axis equation, right? If you come back here, we found out that the equation of the axis is y max plus y min over 2, maximum value plus minimum value over 2. We could kind of write that here. I always prefer writing my equations down. So you could do y max plus y min 2. I'll get rid of that. Now we could substitute our maximum value and minimum value, for which we have to find it first. We have to know what our maximum value and minimum value is. Here we can see that the maximum value is kind of, the graph is just leaning towards 1, and the minimum value is -6. Sorry, I'll use a red pen here to show my maximum negative values. Max, min, right? Now we can substitute these values in. So this is gonna be 1 plus -6, -6 over 2. This becomes -6 plus 1 over 2, which becomes -5 over 2, which is -2.5. If you try graphing -2.5, we're going to notice that this point is actually exactly in between our graph, or it's the average of the graph, right? The amplitude, now there are two ways of doing the amplitude, right? One way to do the amplitude is where you take this formula and you kind of just apply it here. You just kind of apply it over here, since you know your maximum and your minimum value. Or you could just do, since you know what your what your equation of the axis is, right? Axis equation. You could just kind of find the difference in values it takes to go from here, to go from the axis equation to the minimum value, or the axis equation to the maximum value. Well, I would, just so you guys know how to use the equations, me personally, I would use the equation here. I actually recommend doing both, which one you find easier. I find using the equation here easier. It's completely personal preference. I'll be doing both for you guys though. So y max minus y min over 2. We know our maximum value is 1, so we do 1 minus 6 over 2, which is 1 plus 6 over 2, which is 3.5, right? Because 7 divided by 2 is 3.5. We know, now if we look here, we can see that if we do minus 2.5 minus 3.5, the value is gonna be -6. If we did minus 2.5 plus 3.5, we can see the value is gonna be 1. So that's why it's the difference between our maximum value and the axis equation, as well as our minimum value in the axis equation. So this is going to be 3.5 and this is going to be 3.5. Hope you guys are getting it till here. Now I would now what I would do here, what the other way you could also do it is that you could kind of just subtract -2.5 from 1, and you would still get your value, right? You still get your value of amplitude. So you could kind of do 1 minus -2.5, right? Because you're seeing from 1, how much do you have to go down by to get -2.5? This becomes 1 plus 2.5, which also gives you 3.5. Or you could also do you could also do -6. How much you're going up by -6, minus 3.5. You're finding the difference here. Minus 2.5. Sorry, let me get the eraser. Minus 2.5, because -6 plus 2.5. This is also equals to -3.5, right? You subtract here because you're finding the difference. I'm gonna repeat this as many times as I need to make it clear to you guys. You're subtracting here because the amplitude is a difference from the maximum value, right? Or the minimum value to the axis equation. Now we can see another value. We can see another scenario here. A student is moving a meter stick back and forth progressively with progressively larger movements. Is this periodic? We can see that the first graph, right? We can kind of highlight the first graph here. We can see that this is the first graph, right? Something like that. If we were to duplicate this first graph, right? If I duplicate it here and adjoined it back here, we can see that this graph isn't actually like, it's not really matching, right? It's not really duplicating itself. Therefore, it is not periodic. And if you see something like this on the quiz, I'd say just put a big mark on it, like this. Next, this is kind of like a physics question and a math question, right? We can see that Emma's bicycle, right? Emma has a bicycle wheel with a diameter of 58 centimeters, right? She rides at the speed of 18.2 kilometers per hour, right? She picks up a stone in her tire, right? Now we have to draw the graph. Sorry, this question is kind of wrong here. It's supposed to say cycles. Three cycles, right? Here we can kind of see that. Okay, so let's help ourselves visualize this. I'll draw like a circle here. I'll do like a sketch. Draw like, so we know its diameter is 58 centimeters, right? We know that 2r is equal to diameter. 2 times radius is equal to diameter. So we know 2r is equal to 58. You do r equals 58 divided by 2. 58 divided by 2 is going to be 29. R equals 29. This becomes 29 here. This becomes 29 here. We know the radius is 29. Now we want to find the circumference. We're finding the circumference because that's the distance that this piece of rock is actually traveling. Is this outer area, is this length, or this value? This is the length, right? That this rock is traveling around, right? At this speed. The rock isn't going forward, backward, it's moving in circles at that speed. Moving in circles at that speed, right? So we can kind of say, so if we find the circumference C is equals to 2 pi r. We could also say C is equals to 2r pi. C is equals to 58 pi because I got 2r is equal to 58 here, right? Circumference. Now if we drew a table, right? If we drew a distance, speed, and time, right? We know what speed she's traveling in. We know that this is the distance she's traveling, right? We just don't know what time, how much time it's taking her. That's what we need, right? Like I can draw a incomplete graph here for you guys to know what information we have. So we have the distance she's traveling, right? We have the diameter of the circle, right? Meaning that when the stone, let's say the stone starts here, it goes up all the way here. This is the highest point it's gonna reach, right? It's gonna reach 58 meters, highest point. When it goes back down, right? When it goes back down, the midpoint, the mid area is gonna reach is 29 because it's pretty leveled on the ground. This is 0, so it's gonna be 29. It's gonna be 29 centimeters above the ground. Do 29 here, and we know that the minimum value is gonna reach is 0 because it's a tire on the ground. So the minimum height is going to reach a 0, right? The only value we're missing here I'll put height in centimeter, right? The only value we're kind of missing here or looking for is the time value, because the question does not state the time value. Now we can see that time is actually distance over speed. We know that this is the distance since this rock is traveling at this distance, traveling over this circle again and again, right? The rock is stuck onto the tire and it's moving around in a circular motion at this speed. So we could convert this into an equation. We could do time is equal to 58 pi centimeters over 18.2 kilometers per hour, right? The question is not done here. Here we can see that this is in kilometers, this is in centimeters. If you want to cancel it out, we need to convert this into centimeters. So we could kind of solve this separately here. We can bring this here. We could do 18.2 kilometers per hour, right? We know one kilometer is 1,000 meters, so we could do 18.2 into 1,000, right? 18.2 into 1,000, that's gonna give us 18,200 meters, right? Meters over 1 hour. We could convert that into centimeters. We know 1 meter is 100 centimeters. So we could just multiply 18,200 into 100, which gives us 1,820,000 centimeters per hour. Right? We have that now. Now it wouldn't be inappropriate. It wouldn't be like really appropriate of us using an hour, because think about it. She's riding a cycle, right? Do you really think that while you're riding a cycle and if a rock gets jammed on your tire, do you think it's gonna take a whole hour for the rock to make one circular motion? No, it isn't. So we would convert this hour into seconds. So we know 1 hour is 60 minutes, which is, so this is 182.123 centimeters by 60 minutes. If you want to convert this to seconds, you could just multiply by 60 again. Centimeters by 3,600 seconds. Now that we can see this is a fraction and it's the same thing as this, we can see that it's a fraction in the denominator. So whenever this occurs, you kind of just reciprocal it. So this becomes 58 pi centimeter, right, into 3600 seconds by 1820 to 3 centimeters, right? Sorry, my numbers are kind of overlapping. I'll just bring this here. Now that I have this down, I could solve for seconds here. I could cancel centimeter. Now I could do 58 into 3,600 gives me 208,800 seconds divided by 1.82 million, right? So divided by 1.82 million, that's gonna be 820 be we have to do 58 into pi, right? 58 into pi, do 3,600 divided by 1820 gives us this value, right? If you did it correctly, you should be getting something such as 0.36. You do 58 into pi, do this, you multiply by 3,600 and divide everything by 1.82 million, right? So now you can see that this value is there only for one cycle, right? Because this is the time it takes for one circular spin to occur. Since the circumference is 58 pi, right? It's only once, right? It's only once. We didn't calculate triple circumference, right? Or anything. So we know that this is its period. 0.36 is its period because that is the amount of time it takes to do one entire circular spin. So we could kind of plot that here. This becomes 0.36, right? You could add that plus 0.36 becomes 0.72. You could add that with 0.36 too. Becomes 1.08. 0.08, right? And you kind of just draw here. So we know our value is going to start at 0, right? It's going to go up to 58, come down to 0.36, and it's just going to keep doing this, right? It's just going to keep doing this. It's going to go up to 58, come back down to 0.36, go up here, come back down, go up here, come back down. So this is us graphing 3 cycles, right? This is time, seconds. Hope this video was helpful. Hope you guys enjoyed it. Stay tuned for more. Hope you guys do good on the math quiz on Monday.